All right, so I'm going to do this one last example. If you haven't already done it yourself, then please try it yourself before you just copy down what I'm doing. All right, so let me fix this. So for my piecewise function, I have a constant function, which should be up there at 7, a cubic, and a square root. So let's start with the constant. If x is less than -1, so I'm going to put the endpoint. So at -1, I'm going to go to 7, 2, 3, 4, 5, 6, 7. It's an open circle since it's less than and not less than or equal to. It's a constant. This is basically y equals 7. Oh, well, maybe I'd make a better line. So it looks like this. Okay. Then I'm going to get my endpoint here. Going from, now I have 2 endpoints, so I think I'm just going to go ahead and do them both here. So I've got -1. When I substitute that in here, -1 cubed is -1, minus 1 is -2. So I'm going to go to -1, -2, and that's a closed circle because it's less than or equal to. And then at 2, I have, I'll substitute that in. 2 cubed is 8, minus 1 is 7. So at 2, 1, 2, I'm at 7. 1, 2, 3, 4, 5, 6, 7. And that's also a closed circle. Okay, so those are the endpoints of the part of the cubic graph that I'm going to have. So for my cubic, I have 5 anchor points. Okay, instead of starting from left to right on this, I think I'm going to start in the middle because then I can kind of see which part of the graph I actually have here. So I'm going to start with 0, 0. So I'm going to put my pencil at 0, 0. Again, if you want to write out what these are, you are welcome to do that. But all I'm doing here is translating down 1. So this is my new point. Okay. Then if I do my -1, -1, and I translate down 1, that is that point. So this point here is going to be out of my domain, so I'm not using that. So I'm going to go to 1, 1. So go to 1, 1. All I do is translate down 1. So there's that point. Then I'm going to go to 2, 8, 2, 2, 4, 6, 8. But then I'm going to translate down 1, and there's that point. Okay, so that's what I have there. I just happen to hit on the endpoints. That won't always happen. So then I draw in my graph. Okay, no arrows because it's a restricted domain. I only get the curve, and that there is a point of inflection there. I just didn't really get it in there very well. Let's see if I can do that better. It still kind of looks like a line, but there is a point of inflection there. It's just hard to do when you can't continue things on. Okay, so now on for the third part, x is greater than 2. So I'm going to substitute in 2. 2 times 2 is 4. I take the square root of that, that's 2. Make it negative and add 1. So that's going to be -2 plus 1, which is -1. So I'm going to go to 2, -1, and it is an open circle. Right? So then for my square root function, I have anchor points at 0, 0, 1, 1, and 4, 2. So I'm going to go to start at 0, 0. That negative means I reflect in the x-axis, so I don't go anywhere. That 2 means that it is a horizontal compression by 1/2, so my x value times 1/2 is still 0. And then I add 1, and it's right here. So I don't get to make that point because that's not in my domain. So then I'm going to go to, excuse me, I'm going to go to 1, 1, and then I'm going to reflect in the x-axis, so it's down here. I have a horizontal compression of 1/2, so I end up right there. And then I go up 1, also not in my domain. So then I'm going to go to 4, 2. And then I'm going to put my pencil there. I'm going to reflect in the x-axis, so it's down here. Horizontal compression by 1/2, so that's here. And then I go up 1, and I'm there. So I'm out of anchor points, but I still only have 1 point, and that is definitely not enough. So if I'm using 1, 1 and 4, 2, I need another one that would make sense. An easy square root is going to be 9, 3, right? So I can go to 9, 3. So this is 2, 4, 6, 8. So 9's over here, but that's okay because we're going to fix things here. And I'm going to go to 1, 2, 3. So this is 9, 3. I reflect in the x-axis, so I end up down here. I have a horizontal compression of 1/2, so this x value of 9 becomes 4.5 or 4.5. 1, 2, 3, I think that's 4.5. And then I go up 1, and there's my point right there. And then I can even do, let's see, that was 9, 3. So I could do 16, 4. Okay, so 16 is way out here, and I go up 4, right? So I would reflect in the x-axis. Then my x value really right now is 16, but when I have a horizontal compression by 1/2, it becomes 8, and then I go up 1, and I have this point right here. Okay, so that means that my graph looks something like this, but better, always better. Try that again. It is a curve, it's not a line. The curve isn't curvy very well. I don't know why I can't do that. Okay, that's a little bit better. I'll make my points a little bit bigger. Because remember, this is a curve like this, it just got reflected down on the x-axis. Okay, so my domain here, start at -infinity, keep going. This isn't included, but it is here. Keep going. This is good, so I'm going from -infinity to infinity. My range. So this means I'm going to start down here at -infinity. As I go up, this isn't included, but it is here. So I keep going. My 7's taken care of, but I can't go past that. So I'm going from -infinity to 7. Never include my infinities, but this I do have a y value of 7, so I am including that. And then here I have 2 discontinuities. They are both jump. And it is at x equals -1 and 2. And there you go.